Have you ever been sitting on a plane, looked up at the lights, and just wondered? Today, we are diving deep into the hidden nervous system of an aircraft, that incredibly complex electrical grid that honestly makes modern flight even possible. Let's get into it. So, picture this. You're cruising along at 30,000 feet. You flick on your reading light, and it just works. But where is that power really coming from? I'll give you a hint. It's not some giant battery pack. The real answer is directly connected to those massive engines holding you up in the sky and a whole network of gear working perfectly together. So, to trace the journey of that electricity all the way to your reading light, we first need to zoom out. We've got to look at the big picture. What is this entire system actually built to do? Well, when you boil it all down, the plane's electrical system really has three main jobs. First, it has to generate the power from scratch. Second, it has to regulate that power, keep it stable and safe. And finally, it has to distribute it everywhere it needs to go, from the pilot's flight controls to the coffee maker in the back. Now, what's really cool is that airplanes don't just use one type of electricity. They actually use two. For all the heavy lifting, the big systems, they use a powerful 115-volt alternating current, or AC. But for all the delicate electronics and smaller gadgets, the system converts that power down to a much safer, lower voltage, 28-volt direct current, or DC. All right, so we know the system generates power, but how? Where does it all come from? Let's go right to the source and see where all this energy is actually born. This is really the heart of the whole operation. It all starts with those huge jet engines. See, as they're spinning like crazy to create thrust, they're also spinning an electrical generator that's attached to them. It's basically like a super-powered version of a dynamo on a bicycle. Inside that generator, spinning magnets fly past coils of wire, and that motion creates a massive flow of electricity. So get this, the very same force that's pushing the plane through the sky is also lighting it up. But why go through all this trouble? Why is electricity the go-to power source for planes? Well, for starters, it's clean. No smoke or ash inside the cabin, which is a good thing. It's also incredibly versatile. You can turn it into light, heat, or even physical motion with no problem. And finally, it's just really efficient to send it all over a giant airplane using simple wires. Making a ton of raw power is one thing, but controlling it and making it safe, that's a whole other ballgame. Now we're going to look at the system's gatekeepers, the components that manage the flow and keep everything in check. The first, and maybe the most important gatekeeper, is the master switch, right there in the cockpit. This is the pilot's main control. You can think of it like the main circuit breaker for your entire house. It lets the pilots connect, or totally disconnect, all the electrical systems from the generators. But what about protecting every single little component? Well, that's the job of the circuit breaker. If any single device, say a navigation screen, starts pulling way too much power, its circuit breaker will pop automatically. It just cuts the electricity to that one spot, preventing damage or, something much worse. It's an absolutely critical, automated bodyguard. And this right here really shows you how far safety tech has come. See, older planes used fuses, which are basically just tiny wires that melt if they get overloaded. The problem? You have to physically replace them. Modern circuit breakers, though, they're more like resettable switches. If one trips, the pilot can often just push it back in once the problem's fixed, which, as you can imagine, is a huge advantage when you're flying. Okay, the system uses a few key parts that can sound alike but do totally different things. A switch, that's easy. We all know that. You flip it to turn something on or off. A solenoid is different. It takes electricity and turns it into a physical push or pull motion, kind of like an automated door lock. And then there's the relay, which is super clever. It's like a force multiplier. It uses a tiny bit of electricity to flip a big switch that controls a much, much larger flow of power. So, we've seen how power is made and how it's controlled, but what happens if the main generators on the engines just fail? This is where aviation's obsession with safety and backup plans really, really shines. Let's look at the fail-safe systems. The very first line of defense is the onboard battery. In fact, before the engines even start up on the ground, the battery is providing all the power. Once the plane's in the air, the generators are constantly recharging it, so it's always ready to go as a vital backup. If those generators were to go offline, this battery is what powers the most essential flight instruments. Okay, so the battery can back up the instruments. Great. But what about the engines themselves? How do they keep running if the main electrical system completely dies? They need a spark to burn fuel. Where does that come from? The answer is this incredible little device called a magneto. A magneto is basically a mini, self-contained power plant. It gets spun by the engine itself, and its one and only job is to generate the high-voltage spark for the spark plugs. And here's the most important part. It is 100% independent of the plane's main electrical system. So just how important is this completely separate system? It all comes down to this number. 2. That's right, not one, but 2 totally separate magnetos on every single engine. This is the heart and soul of aviation safety: redundancy. If one magneto fails for any reason, the other one just keeps on firing, and the engine keeps on running. It's that old pilot saying, 2 is 1 and 1 is none.
Okay, we followed the power from the engine through all the controls, all the way to the failsafes. So for our final stop, let's head up to the flight deck and see how all this electricity finally comes together to help the pilots fly the plane. You know, modern airliners use what's called a glass cockpit. All those old-school analog dials and gauges, they've been replaced by these huge digital screens that show everything the pilot needs to know. But of course, these amazing displays are totally dependent on a steady stream of electrical power. But you guessed it, there are fail-safes for the fail-safes. Even if the main power goes out and those big screens go dark, just remember, the magnetos are still spinning, the engines will keep running. And for the screens themselves, there's another dedicated backup battery that can power the most essential displays for up to 30 minutes, giving the pilots more than enough time to sort things out. So there it is, from the spinning core of a jet engine, through a web of wires, circuit breakers, and layers of backups, all the way to a single tiny pixel on a pilot's screen. That is the incredible journey of electricity on an airplane. It's a powerful reminder of the immense, invisible complexity that makes flying an everyday miracle. It really makes you wonder, doesn't it? What other hidden systems are up there, working tirelessly just out of our sight?